Hi, my name is Hongyi. This video is for IBM Data Science Capstone project. My topic is repeat purchasing probability prediction. This project is from Alibaba Tmall competition. Uh, this competition requires us to predict whether a user will repeat purchase a product from a certain merchant. If they repeat purchasing, no matter what the product is, repeat purchase a product from a certain merchant, the label would be one, and vice versa, the label would be zero. To do this kind of job is quite useful for both merchants and Alibaba platform. For the merchants, they can build, better relationships with those potential customers more efficiently, so that they can make more money from it. And for Alibaba, they can have a better recommendation system, and they can make more customized recommendations for their users, based on the predictions. And for the data exploration part, we have two categorical variables. One is gender, and the other is age range. There are many known values in the data set, and I changed the noun values to zero, which means unknown. Which means we don't know their value, and so we can see three bars in the chart. The mean value represents the probability whether this kind of person will purchase a product from different merchants. Also, we have many numerical variables. Uh, if we take U6 and U8 as examples, I simply group by the person based on their how many based on them, and for example how many times they purchase or they clicked on the website of different merchants. As we can see from the chart, the more often a user clicked on a website, merchant's website, the higher probability that they will have to purchase or to repeat purchase from that merchant. And it is the same situation for the U8, which represent how many times they add an item to their cart. For the feature engineering part, the main logic here is group by and merge. For the merges, I created 5 features. For the users, I created 7 features. And also I take the interaction into consideration, the interaction between user and merchants into consideration, and then created 8 features of it. For example, we can have like M1, which means how many times the merchant is visited or clicked by the user. And M6 to 9 represents counts for each action type. When I say action type, it means click, add to cart, purchase, and so on. Then for the model training part, I used the Spark machine learning package, which is the Python version of Spark. And I used mainly 2 tree kind of models. One is gradient boosting decision tree, which is a boosting model. Another is random forest, which is a bagging model. And I set the parameters into default. For example, the max iteration was 100. And then I used the accuracy rate and the area on the analysis curve at the main evaluation matrix to evaluate our models. Then I put the data into the model, and we get the test error Yeah, I split the data set into two parts. One is the training part, and the other is the testing part. And the ratio was 7% of the data, the training part, and 30% is the test part. And we can see the area of the random forest is 0.0613. And the error for the gradient boosting decision tree is 0.07615, which is a little bit higher than the random forest. But for the ROC score under the curve, random forest got 0.6315 and GBDD got 0.6611. So for the ROC score, gradient boosting decision tree had a greater performance than the random forest. And then I created more features to do the iterative feature creation part. I think the ratio features might be important, so I get the ratio features. For example, how many times I used, how many times user clicked on the website of a certain merchants, and then divided the value by how many times they actually purchased products from that merchant. And then I trained the two categorical variables into the dummy variables. And then I trained the model again. Surprisingly, the performance of the model actually decreased. And we can see the ROC score of GBD decreased to 6611, and the performance didn't, the new features are not so useful in this specific case. And then I did the grid research, to find the best parameter of this model. When I do the grid search, I just based on the gradient boosting decision tree. As we can see, when the iteration equals to 100 and the sample rate equals to 1, the model had the best performance, and the ROC score is just 0.6611. Yeah, that's all for the presentation, and thanks for listening.